Hello everyone. This lesson will show us how to design a model with Chinese code. SSDD is the Chinese code design parts which is associated with STAAD.Pro. So the SSDD, you can view model, design model, check model analysis and design results. Design a drawing connection and output a model report and drawings. But the modeling should be done in STAAD.Pro, and the model should only contain the primary load cases, because we can create the combinations, wind loads, seismic loads, cooling loads, notional load, and mass load through load wizards in SSDD. Load wizard is a tool that can conveniently create these loads, which are following the Chinese code. Now let's open model in STAAD.Pro. This is a model that I have completed geometry modeling. This model only contains two primary load cases, dead load and live load. OK, now we close the model and open it in SSDD. We choose General Steel. Now we open it in SSDD. In SSDD display interface, we can view the geometry parts of the model, such as mark all the dimensions of the members, display selected members, and so on. In addition, if you right-click the mouse, there is a lot of shortcuts you can use in your design. And press space key, there is a lot of quick commands. OK, now let's analyze and design the model. At first, we should modify the load cases of the model. We use the load wizard tools. In these tools, we can add, modify, delete a load case, but the values could only add and modify in commander fields. Now we add a response spectrum seismic load case. We should select a model shape combination method from SRSS or CQC. Here we choose CQC. Then we choose the direction of the seismic and enter the effective factors. If the model contains the vertical seismic load, the with vertical shape freedom should be selected. Here we only choose X direction and Z direction, and the factor is 1. Now we input the effective gravity load of the model. You can select a load case and enter a load factor, then add the load case to the right selected column. Then click OK. Then we generate the response spectrum of the model and set the design parameter according to the GB50011 and 2010. Here we cite the earthquake is frequent. Group 2, Class 7, Set Class 2, and dump ratio is 0.004. If seismic acceleration zone is 0.3, you should choose this option. We set the characteristic period is 0.4. After all the parameters are entered, then we click OK. We can preview the load case. Now we click OK. We add 2 seismic load cases into the model. Now we add the 1 load cases. At first, we should decide whether consider the structure shape factor. If you choose Mesa 1, the right figure scale will be used in the model. If you choose Mesa 2, the right figure scale will not be considered in the model. This time we choose Mesa 1. Now we set the wind parameters according to the GB50009 and 2012. Here we set the primary wind pressure, 0.3, ground roughness, Class B, building total height, 9 meters. If the model considers the wind dynamic factor, we can select this option. Here we can choose to create 4 vertical wind loads or create an inclined wind load at the same time. Here we only create 4 vertical wind loads. Now we enter the figure scale. This is the fourth direction of the wind loads, and this is the fourth face of the building. These values are the wind shape coefficient of the building. We keep the points count, no changes. Then click OK. Here we get 4 direction wind loads. If the model contains current load or need notional load, you can also add it through the load tools. Now we perform the load combination. The first item is the force factor setting, and the second item is the displacement factor setting. The default factors are the value in the Chinese code. User can adjust the coefficient according to their own needs. We can create a user combination or perform the auto combination. Let's perform the auto combination. We need the force combination, displacement combination, and seismic combination. We click OK. These are combinations generated according to the Chinese code. In the following page, we can look at the primary load and load combination. Now we save and exit the load tools. Then we save the load cases. We click Yes. We will analyze the model later. Now we click No. Then we create the guidelines which will be used in the drawing production. Let's click Guideline button and click New. The software will automatically generate the corresponding guidelines. If you need to customize guidelines or need oblique guidelines, you can change guideline settings. Here we keep them no change and click OK. And we close the work frame. Then we define the cut planes that can be used to create drawing. We can generate cut plan from one frame, 3 points, 1 point plus 1 plane, and 1 point plus 1 element. Here we choose generate from one frame. We can review the plane from the plane name. Let's perform the analysis of the model. We can review the analysis result of the model. Let's click the Analysis Result button. From the Analysis Result viewer, we can review the member force, the node displacement, the intersection displacement. From the Detail Data page, we can review the force detail of the member, select some members, and load cases. The force detail page will be occurred. From the force detail, we can review the force and the displacement information. We can also cite the section number. Now let's set the specifications. If the model contains a member, the member they frame into will not be considered as restrained. We can set it into a secondary member. It will affect the effective length of a member. If a material doesn't contain in the member database, user can add it themselves. This time we keep them no changes. Now let's define design parameters. For this model, we can create 3 kinds of design parameters. They are gather, subbeam, and column design parameter. Then we click Add. In General Parameter page, we name the parameter with main beam. Mem tab, Bentley member, steel number Q235, section slenderness grade S3, and seismic measure grade 3. Be careful, if you want to consider the seismic, your model should contain the seismic load cases. If you want to use the capacity factor of seismic, this should be selected. If the model needs optimization design, this should be selected. If the model needs vertical check, this should be selected. Here we cite safety ratio 0.3, the failure ratio 0.9, force load list all, displacement load list, we choose 66 and 88, and we click OK. The other parameters should also needed to add according to the Chinese steel specification. For the column, pay attention to the effective length parameter. Now we keep others no changes. We click OK. Then we add a new group design parameters. We name it subbeam. We set the member type Bentley member and the steel number, no changes. Section slenderness grade, no changes. And we don't consider the seismic. We change the displacement load list. We choose 66 and then we price shift and price select and then we price OK. OK, we set the subbeam. Then we add a new group of design parameter. We name it with column. We set the member type column member. And we set the steel number, no changes. And we set the section slenderness grade, no change. And we consider the seismic measure grade 3. And we use the capacity adjustment factor of seismic. And we keep the other no changes. Now we finish the design parameter setting. We can add the model parameter with text. We can also save these model design parameters as a template. So next time, if we have a similar model, we can use this template design parameter by click Load Template. Next, we choose the corresponding design parameters and then assign to the corresponding member. At first, we choose the target design group membrane. Then we switch to the Select interface and select X. All the member parallel to X will be selected. Then we choose Assign to Selected and Assign. The same we choose the target group subbeam. Then we switch to the Select interface and select Z. All the member parallel to the Z will be selected. Then we choose Assign to Selected and Assign. The same with column. We choose Y and choose Assign to Selected and Assign. Now we close the design parameter page. So now we can do the code check. In the member or element option, we can design all member or selected member. If you use design selected member, the member should be first selected and then do code check again. If the model needs seismic design, you can select the seismic design icon and choose a proper seismic precautionary intensive. Here we choose class 7 Be careful. If the model need consider seismic design, the model need contains seismic load case and the seismic measure grid in member design parameters should also be selected. The optimize option can be optimized by group and fast. An interaction number should be entered. The SSDD will calculate and check according to the number of interactions entered. With the group optimized selected, the section in the group will be the same. When the fast optimize selected, the software will calculate from the minimum section until the section meeting the checking calculation is found. This method is fast, but note that the section table should be sorted according to the section area. If the fast optimize don't select it, the software will find the section with the smallest area in the section database and can meet the specifications. You can also set the default design parameters. If there are members in the model without design parameters, the software will use the default design parameters. In Check Item option page, you can use the Control key on the left to control the terms of software checking. For example, we clear all and select the strings. The relevant strings courses will be selected and checked. This time we choose Select All. In Brace Angle page, we can set the angle between the brace and beam in both directions. When the angle is exceeded, the brace will not work. We can also set the member extend angle. When the angle is exceeded, the extended member will not work. We design all member and consider the seismic design. We don't need group optimize and fast optimize. Then we click OK. After code check finished, the design result dialog box will be opened. From the general information page, we can check the design results, control item, ratio, actual value, limit, control force. From the detail page, we can check the detail of check terms. The members that fill in code checking will be specially listed here field. Over-conservative members will be listed here. The relevant design parameters of the member will be displayed here. If the model is optimized, the optimized results will be displayed here. We can output check result into Excel or Word. The dialog box for defining design parameters and design results that we just introduced are old version display dialog boxes. We can change the old version into the new UI by check Option, Configuration, and Code Check and unselected this icon and click OK. Let's review the design parameters dialog and edit. This is new design parameters UI with the mouse points to the parameter on the left. The Revelator Happy field is displayed on the right. Let's back to the design results. This is new design results UI. The right one are the field members. When selected a member, the design detail will be occurred in the right. This is member section. Check items and parameters. Double-click the left members. The results page will be occurred. In the result page, user can change the design parameter again, including the section. For example, we change the section to HW350 and recheck the member. The new design results will be occurred in the right. We can also write back the section by clicking this button. Be careful, note will pop out. Then we close it. Now we close the results interface. The Apply Optimize results will be highlighted. Because the section had changed, the model needs analysis again. We click this, and we click Yes. We should recheck the model. The section will change to HW350. Okay, let's look at the checking result in detail. We double-click this member. In member checking result, we can see the section name, loaded cases, false, design parameters, section material, and the section material detail, and the results. If you want to view the detailed calculation process, you can click Formula button. Here we can see the details checking process of each clause. If the Formulas button don't select it, the check result will be given in simple output. You can also output the checking result of a single member to Word or text. We close the result interface. After the design finished, we can implement a connection design. We can automatically create connections at all locations in the model or create a connection manually. Let's do generate connection and click Yes. Double-click the automatically created node connection on the left to enter the node connection dialog box. We can select different kinds of drawing type to form the drawing connection. Here we choose LZGE. and we click OK. Now we enter the drawing workshop. In Customer Information Interface, we can review the member loads and section information. In General Information, we can set the drawing design parameters. Here we keep a no change. The other interface as a setting of the drawing parameters. Let's keep them no change and click OK. Then the drawing check results will pop up. Here we can view the checking results of currently set parameters. You can also save the drawing results as a text field. Here we close and click Yes. Now we create a connection manually. First, we select a column and beam. From the right interface, we click the column and set the member type column and click OK. And we click beam and set the member type to beam and click OK. Then we can create this connection. We click the Create Connection button and we enter the drawing connection design interface. We choose the drawing type. This time we choose this kind of drawing type and we click OK. Now we enter the drawing workshop. You can change the connection diameters as you own need. This time we keep them no changes and we click OK. We can see the check results. We close the check results and we close Yes. Then the drawing detail information will pop out and we click OK. The drawing connection will be finished. At the same time, the corresponding joint drawing will be generated. This drawing connection is generated by our manual design. Others are automatically generated by software. Now let's enter the report page. From the list on the left, we can choose the options we want to output, like the material and section information, support and member released, load cases, false information, deform information, code check information. We can also control the detailed output contents in the output options. After selection, we can generate reports in the software or directly generate Word reports or export the report to Word or text. Let's generate the report in the software. Here we got the report. Now let's enter the drawing page. Here we can generate joint, plane, member, false drawing of the model. Here in configuration, we can adjust the relevant drawing parameters. Here is drawing connection drawings. Here is the plane drawing. That's the card plans we created under module modeling and analysis. Here is the member drawing. Here is false drawing. We can also export drawing to safely recognize the formats .dxf. The above is the operation and use of SSDD. Thanks for your watching.